Welcome to Science Made Easy channel. A channel you will not want to miss.
This is Science Made Easy channel. As you all know, we are always committed to you. So we start solving different topics on JAMB syllabus. So from now, and we I know that you have seen the JAMB syllabus. You have seen the JAMB syllabus. The first topic on the JAMB syllabus is separation techniques. Separation techniques. So we're starting from separation techniques in chemistry. So we're solving different questions in JAMB syllabus on chemistry. So separation techniques. So now, one thing is that we just doing the revision, and those that do not have an idea of it before, I know that you really catch up with the way we're able to treat the topic. So now, so let's first start about defining what mixture is. Mixture is contain two or more substances that are not chemically bounded together, that can be separated by physical means. For example, if we have two or more substances together, those substances that can be separated by a physical method. So that is what we call mixture. For example, if you add Gary and water together, that one is a mixture. That will become what? Gary solution. If I add salt and water together, it will become a mixture. If I add my salt and Gary and sand together, they have become a mixture. So mixture just means adding two or more things together. That is what we call a mixture. So, and you have this diverse way of separating these mixtures. So, and the ways of separating this mixture, I categorize them into about 6. I categorize them into about 6 or 7. So, the first one is what? Separating insoluble solid from liquid. So if I want to separate insoluble solid from liquid, the best method, we have about 4 methods I can use to separate insoluble solid from liquid. Now, the first method is filtration. Filtration is sterilization as part of the separation techniques, as part of the separation of mixtures. So, and I know normally we would have heard about filtration and crystallization before. This might not be the first time of hearing that. And these are the things that we ourselves practice daily in our daily activities. So today, filtration. So when you hear the word filtration, what first comes to your mind? I know filtration is what? Is the method used to separate insoluble solid from a liquid. You separate insoluble solid from a liquid. Let's look at an example. For example, if I add sand and water together, can sand be soluble in water? I know the answer is no. So, for example, I have sand plus water. This is my sand. Add sand and water together. So adding sand and water together, only one thing is that this sand is not soluble in water. So when you add sand and water together, you see the sand at the bottom and you see the water on top once it has settled. So what can I now separate this? How can I separate sand from water? I know that this question might have also been in your mind, that I mix sand, I also mix water together with sand. How can I now separate sand from water? This must be one of the questions in our mind. So one of the ways to separate sand from water is using filtration. Is using what? Filtration. Let's check the process. How we use filtration to separate sand from water, or how we use filtration to separate insoluble solid from water. Now, the first process is that the mixture of this sand and water will be poured into we have a setup. The setup is we have a funnel. I know you have seen funnel before, whether at home, even whether you use funnel at home. And we have what we call a filter paper. We have what we call a filter paper. Filter paper is circular. A circular paper like that was made, that was folded to be in the shape of the funnel. It was folded to be in the shape of the funnel. So we'll be having something like this. Let's talk this. We have something like this. So it should be molded to be in the shape of the funnel. So, and once we put the filter paper that was supposed to be in the shape of the funnel, we're putting it into the, let's say this is our container. Let's say this is our conical flask. And we have a funnel here. This is our funnel. We put our funnel inside our conical flask. And the filter paper too will be folded in the shape of the funnel. And will also be placed inside the funnel. Then after that, we pour the mixture of the water and the sand. We pour it inside. We pour it inside this funnel, or inside the filter paper in the funnel. So once we pour it inside the filter paper with the funnel, we'll be seeing some water droplets coming. Water droplets coming inside the conical flask. Be seeing from water coming inside the conical flask. And this water that is coming inside the conical flask that been separated, you see that it's very, very neat. Normally, when we mix the sand and water together, the water will be very dirty. But once you use your filter paper and use your filtration apparatus in separating it, you will obtain a clean water inside this conical flask. And this water that drops inside this conical flask, we call it our filtrate. So the water is called filtrate. We call this water our filtrate. We call it our filtrate. So, and what happens is that the sand will remain inside the what? Inside our filter paper. And that sand is called our residue. That sand will be called our residue. It will be called our residue. It will be called our residue. So, and that is how our filtration is being formed. And that means we can now obtain our clean water from the sand using our filtration apparatus. So you can see it from the note here. So the next thing is crystallization. So when I know that we have heard about crystallization, the word crystallization also before. So what do we mean by crystallization? This crystallization usually is to obtain a soluble solid from solution. Example of soluble solid. Let me say that we have salt and water. Salt normally is soluble in water. So if I want to obtain that salt from water, how will I obtain it? For the first thing is that after mixing the salt and water together, I will boil it. I will eat the salt and water. And what happens is that when we keep eating the salt and the water, you will see the water being dried up little by little. So till we obtain a saturated solution. What do I mean by the saturated solution? Till solution becomes saturated. What do I mean by that? That means the water would have dried up to some extent. That the quantity of water that remains won't be that much compared to the first time. And that means the salt become more saturated. And the next thing is that what? We left it to be cool. After we left it to be cool, we see crystals formed. We see some crystals formed. You can see a crystal formed from the solute separate from the solution. Now, filter after that, we can now able to, since the what are they calling it? The quantity of water inside that source will not be that much again, but it will be somehow wet. So we can now separate the salt, the remaining small salt and the water. We can able to separate now from what? Using our filtration apparatus. So that means we filter the water away from the salt. Then we can able to obtain our soluble, our pure salt. So that is what we call crystallization. Heating the solution of water and the salt first until it becomes saturated. Then it will form a crystals. Then after that, separating the crystal from the water to obtain our pure salt. So that is on the crystallization process. I know you love it. I know you love this class. So thank you so much. So we continue again. Thank you. So that will be the end of today. Thank you. So this, when you're talking about distillation, is one aspect of chemistry, or is one part of separation techniques that used to separate two mixable liquid. That means here we are talking about liquid. We are not talking about whether solid and liquid. We are not talking about solid and gas. We are talking about liquid, two mixable liquid. So that is what we usually use for what? Distillation. So normally we usually define distillation as a method to separate soluble solvents from solution. That means a mixable solvent from solution. And normally we have two types of distillation. We have the simple distillation and we have the fractional distillation. So our simple distillation, which is the normal distillation, usually is to separate two mixable liquid with different boiling points. That means if there is a difference in their boiling point, what we use is what? Distillation. We use distillation to separate two mixable liquid with different boiling points. For example, now, if I want to separate ethanol and if I want to separate ethanol and water, this is my ethanol. Normally, the boiling point of ethanol is 78 degrees Celsius. The boiling point of ethanol is 78 degrees Celsius. But if I separate ethanol and water, and my water, the boiling point is 100 degrees Celsius. It's 100 degrees Celsius. So if I separate the two of them, you can see that their boiling point is different. So I can able to, and if you mix ethanol and water together, you see that they are mixable together, like they are mixable. Even you can't even know the difference if you mix both of them together. That means those two solvents are mixable together, but they have different boiling points. So the kind of method we can use is the simple distillation to separate this. So, and let me explain the process that we use in our distillation. So one of the things is that when we are distillating, we have some apparatus we use it for distillation. Distillation container, we have the distillation flask, we have the Bunsen burner, we have the wire gas, we have the conical flask, we have the condenser. So on our mixture, which is the mixture of ethanol and water, we put it inside the what? Distillation flask. This is our distillation flask. Distillation flask usually have a mouth here. I also need a thermometer and a cork. So on top here, we fix our thermometer. On top here, we put our thermometer here. We shook the thermometer inside the cork. So that it can be covered, so that there will not be any gas that will be going out of the distillation flask. So it will be an airtight something. So we put in our cork on top of the distillation flask. And in this mouth of the distillation flask, we tighten our condenser inside it. We tighten our condenser inside this. We tighten our condenser inside this. So let's say our condenser is like this. Sorry, I'm just demonstrating. Let's say this is our condenser. And in the mouth of this condenser, we tighten a pipe, a tap, and this is our conical flask. So, and we put our resource, we put a resource stand here to hold our condenser. So that the condenser will not fall. And our what are they calling it? Our bouncing bone, our heat source here that will be supplying heat for us. And inside we have inside the condenser. So and we are in the mouth of all these the condenser, there's a hole where you pass a pipe to be passed here, a pipe to be passed here. One of the pipe will be put inside water so that it will be cooling the condenser. So that it will be cooling the condenser because it will be summer hot. Whenever the heat is being passed, it will be summer hot. So we on the one of the pipe we put inside water so that it will be cooling the condenser when it is hot like that. So in the mixture of our ethanol and water will be here. The mixture of ethanol and water will be here. So what happens is that as they are being heated, gas becoming once is 78 degrees Celsius. Once this thermometer, I've been watching this thermometer. One thermometer is 78 degrees Celsius. Our ethanol, which is the one that has lowest boiling point, will be coming out as a gas. Be coming out as a gas, and as it's coming out as a gas, it will be going into this condenser. What's the work of the condenser? The work of the condenser is to convert the gas into what? Convert the gas into a liquid. And the ethanol will now be coming out here once it's 78 degrees Celsius. And we must not allow the temperature reach 100 degrees Celsius before we stop it. Because once it's reached 100 degrees Celsius, water will be coming out. And it might mix with the ethanol that we are separating. It might mix with the ethanol we are separating. So another one here is so we have another one here. So after that, we can now move to the fractional distillation. Fractional distillation. So the work of fractional distillation usually is to separate two or it also used to separate miscible liquid. But when the boiling point difference is small, when they have a very low difference in boiling point, so that is when you can use what? Our fractional distillation. So for example, if you are to separate what you are to separate our crude oils. So that's why fractional distillation is employed in separation of crude oils, because crude oils have a very close boiling point to each other. They have a very close boiling point to each other. So for example, the crude oil fractions, we have the petroleum gas. Petroleum gas has a temperature below 40 degrees Celsius. And we also have our petroleum ligroin. Petroleum heater. Petroleum heater has a temperature range between 2 degrees Celsius to 60 degrees Celsius. To 60 degrees Celsius. To 60 degrees Celsius. We also have our petroleum heater. Petroleum petroleum heater between 60 degrees Celsius to 100 degrees Celsius. So you can see the temperature difference is somehow intertwined. It's somehow very, very close to each other. So that is why the kind of something we use for them is what we use a fractional distillation, because their boiling point are somehow closer to each other. Because boiling point are so close to each other, so we use a fractional distillation to separate them. So example, you want to separate your petroleum gas from your petroleum meter, or you want to separate petroleum. Oh, sorry, this one is growing. This one is growing. So, like, that is how to separate them. So we'll be using fractional distillation to separate crude oils. So that is different between the fractional distillation and our simple distillation. So thank you. So we'll be stopping here. Most of you have practiced decantation before. Most of you have practiced decantation before. So like decantation is when you are using like, for example, when you are separating your gari, like for example, you have a lot of water inside your gari and you want to remove some water from the gari. I know that you let your gari to settle down at the bottom of the cup. Then it's point little by little. Or you are someone that you fetch the water and the water contains some dirt. Like you allow the dirt to settle down at the bottom of the bucket, then start pouring the water little by little. That's decantation. That's the process of what? Decantation. So usually it's to separate what? Dense solid or insoluble solid from liquid. That is also used to separate that. Centrifugation also. We have what we call the centrifuge. The centrifuge is used in the hospitals. Usually in the hospitals, usually to separate something like blood plasma from blood. Like, let me go to that. This filtration, I've explained that filtration. That is the note. Let me go to decantation. Now, this is decantation. I've talked about decantation. And let's move to centrifugation. Now, centrifugation now. You separate what? Suspended particles from a liquid by spinning. Like, for example, you want to separate your blood cell from plasma. Plasma is also inside your blood. But you want to separate that blood cell from that plasma. That plasma is insoluble inside that blood cell. So you want to separate it. We have what we call the centrifuge. A centrifuge machine in the hospital. And when you get some laboratory, you can see the centrifuge machine. It usually contains some parts inside it where we can place our test tubes. You have something inside it where you can place your test tubes. So you put your sample of your blood cell and plasma inside the centrifuge. And what just happens is that when you plug it and when you run the centrifuge machine, it will speed it at a very high speed. And later you see the plasma on top, the blood cell will settle at the bottom. And then you can now decant your plasma from the blood cell. So that is centrifugation. So another thing is magnetization. What do you use magnetization for? Magnetization usually is to separate magnetic substance from non-magnetic substance. If you want to separate your magnetic substance from non-magnetic substance, the method used is what? Magnetization. For example, if your metal is inside water, you can use magnetization to remove your metal from the water. Or if your metal is inside sand, you can use a magnet to remove the what? To remove the metals or the iron from the sand. That is magnetization. So another category I categorize this into is separating soluble solid from liquid. So you want to separate your soluble solid from liquid. That means you have a soluble solid from liquid. The method you can use is evaporation, crystallization, precipitation. Now, your evaporation is very simple. For example, if you have your salt, your NaCl and water, and you want to separate your NaCl from water, what you do is what? You will heat it. You heat your solution of salt and water, and the water will dry up. We usually have it in something like this. Let me see this let me erase this. So the water will dry up and will remain only the salt. So that is evaporation. We can have a bossy burner here like this, and we can have whether our pot, our container, or our beaker. We put some water inside some water inside this beaker. We can put the solution of the salt and water in a petri dish and place it on top of this beaker or the container. This is where our salt and our water is the solution. So we don't want to eat it directly That's why you put it on top of the steam. So once we be drying it up, once we be evaporating this in the steam that is coming from this water, and after some time you see the water dried up and it remains only the salt. The purpose of not eating it directly is so that what this is precipitation. So we precipitate some soluble substance by mixing two soluble compounds or two soluble salts together. When we mix two soluble salts together, it forms insoluble crystals. It forms insoluble crystals, and that insoluble crystals cannot be separated by what? Filtration. Let me go on. Let me go to the notes. This is it. So like we mix two soluble compounds together, and when we mix two soluble compounds together, it forms insoluble crystals, which is a precipitate. And you cannot separate the precipitate by adding what? By filtrating it. By filtration. Sorry for that. So, and that is the note of filtration. You can see it over there. So we can use filtration in water treatment to remove impurity from water. So if you want to remove impurity from water, you can add a soluble salt like NaC or inside the water, and it forms some crystals. That means there are some impurity, there are some soft salts inside that water. So all those dissolved salts will come out as a crystals, as a precipitate. Then you can also separate them using filtration. So you can use it to purify water, to treat water. You can use it to treat water. So another thing is on separating insoluble solvents from solution. Like if you see an insoluble liquid, to separate an insoluble solvent from solution, normally what do you call solvent, what do you call solution? Normally a solution is a combination of solute and solvent. A solution is a combination of solute and solvents. Solute plus solvents. So solute plus solvent make a solution. Solute is that thing that you want to dissolve. Solvent is that thing that you use to dissolve the solute. We usually use the solvent to dissolve the solute. So, for example, in salt and water now, the solute is the salt, the solvent is the water, because we use this water to dissolve the salt. So, whenever you now separate soluble or insoluble solvent from solution, for example, your palm oil and water, like your palm oil is insoluble in water. So, you want to separate that kind of liquid, two insoluble liquid. You want to separate them from each other. The method is what? Separating funnel. Separating funnel. So separating funnel usually is to separate insoluble solvents from solution, like your palm oil and water from your palm oil from water. Now you can use what? Separating funnel. You can use your separating funnel. So another one is what? Separating soluble solvents from solution. You want to separate your soluble solvent from solution now. We use what? Distillation and fractional distillation. Is what? Sieving. We usually use sieving to separate solid particles of different size. We use sieving to separate what? Solid particles of different size. When we have solid particles of different size, the method is what? Is sieving. The method is what? Sieving. To separate solid particles of different size. So, like for example, your gari, you see that usually sieve your elubo, your cassava flour, usually sieve your yam flour to separate the what is larger particles from smaller particles. Even bricklayer perform sieving to separate stone from the sand. So, and another method of separation techniques is our chromatography. Chromatography is usually to separate